Yes, we are going to be starting optimal mix. Yes. Uh, Under this topic, I will introduce you, talk about the introduction to optimal mix decision. Okay. Then we are going to talk about procedures involved. We talk about constraints. Okay. Constraints or bottleneck. We'll talk about, of course, procedures involved. Procedures involved in optimal product mix. Okay. Then we are going to have illustrations. So let's pick it one after the other. What do you understand by optimal mix decision? The optimal mix decision represents the process of allocating limited scarce resources in a judicious and efficient manner in order to achieve organizations' contribution. It should be noted, let me put it down. Okay. Optimal mix represents the process of allocating limited scarce resources in a judicious and efficient manner. Okay. In order to achieve or in order to maximize, in order to maximize the organization contribution towards profits. Okay. Now, when it comes to optimal mix decision, you want to know because a company, every organization do not have the required resources to satisfy customer demand. All right. No company in the entire world has sufficient resources to maximize contribution. Therefore, the little you have, how to allocate it among competing product line is what optimal mix or linear programming how to achieve. All right. However, it should be noted that optimal product mix is used when there is only single constraint. When there is only one constraint is when you use optimal product mix decision for the purpose of allocating limited scarce resources. So let's put it down. The optimal product mix is used when only one factor of production, when only one factor of production is limited in supply. Okay, so that's the introduction to optimal product mix. Now, what we are saying is that when a company does not have sufficient factor of production, including material kilogram, raw material kilogram, labor hours, or machine time. The limited scarce resources available will need to be allocated among competing products in a judicious manner. All right, that is basically what we are trying to do, which is optimal product mix. Let me just put it down for you. When a company does not have sufficient factor of production, okay, including raw material kilogram, labor hours, or matching time, the limited scarce resources we need to be allocated among competing product line in a judicious manner. That will enable the company to maximize contribution towards profits. Okay. So let's say, for example, you want to produce and you are going to need material kilogram. You have product A, product B, and product C. The material kilogram required by product A, let's say, for example, is 5 kilogram, B is 4, then C is 8, for example. The total required material kilogram is 17. Let's say the available material kilogram within the organization, the available material kilogram is 15. So you need 17 kilogram of raw material, but the company has only 15. So there's a constraint. That means the company will not be able to maximize contribution towards profits. Therefore, the little that you have, this 15 that you have, how you are going to allocate it among competing product line is what is known as optimal product mix decision. All right. When you don't have sufficient resources, how to allocate the little that you have that will enable you to maximize contribution towards profits is what is known as optimal product mix decision. So that is the introduction. Then let's talk about constraints. Okay, what do you mean by constraints? This is also known as bottleneck. It represents the resources that is limited in supply. Okay, bottleneck represent the resources that is limited in supply. They are the factors or anything that limits the ability of a company to take advantage of market condition. All right. So let me put it down for you. Constraints. This is also known as bottleneck or limiting factor. bottleneck or limiting factor. It represents the resources that limits or impair the ability or impair the ability of a company to take advantage of market condition or to maximize profits towards profit to maximize contribution or to maximize contribution towards profits. So anything that limits the ability of a company to take advantage of market condition is what is known as a constraint or limiting factor or bottleneck. All right. For example, raw material kilogram may not be sufficient. Okay. Let me just put it down. For example, raw material kilogram. Okay. May not be sufficient. May not be sufficient to satisfy customer demand. Okay. Not only that, labor hours may be inadequate to produce the required outputs. All right. Not only that, matching time may also not matching time may not be enough. Okay, may not be enough to produce the required production. Okay, so when this happens, we said there is a constraint. Like I mentioned in my example above, you need a material kilogram of 17, but you have only 15 kg. That is a constraint. All right. So when this happens, once there's a constraint, that means there's a limiting factor. All right. So there are two types of constraints. Okay. Types of constraints. Basically, there are two types of constraints. All right. One, we have single constraints. Then two, we have multiple constraints. The first one, which is single constraints, all right. This arises when only one factor of production, when only one factor of production is limited in supply. Okay. So, for example, e.g., Raw material kilogram may be inadequate. Raw material kilogram or labor hours may be inadequate. So when this happens, we said it's a single constraint. So yeah. Under single constraints, key limiting factors. Under single constraints, okay, under single constraints, the key limiting factors, the key limiting factor should be used to allocate the limited scarce resources. Okay, so the second one, which is multiple constraints. Multiple constraints. This is used, or this arises, this occurs when more than one, when two or more, let me put it that way, when two or more factors of productions are limited in supply. For example, raw material kilogram and machine hours may not be sufficient. Okay, to produce the required outputs. So when this happens, we said it's a multiple constraints. Okay. Under this circumstance, okay, the linear programming model should be used to determine the production plan that will maximize contribution. Okay, so that's the difference between the two. I said that there are two types of constraints. We have single constraints and then multiple constraints. Under the single constraints, it arises when only one factor of production is limited in supply. It may well be that it's the raw material kilogram that is not sufficient. It may be that the labor hours are not sufficient to produce, all right, but not the two. Only one factor of production will be limited in supply. That is single constraint. So when there are single constraints, then the key limiting factors should be used to allocate or to determine the optimal production mix, okay, that will maximize contribution. The second constraint is multiple constraints. And then the multiple constraint will occur when two or more factors of production are not sufficient. When two or more factors of production are limited in supply, then we need linear programming to be able to allocate the little resources available in order to maximize contribution. Under this, of course, uh, linear programming model will be used. Okay, linear programming model will be used. So our focus will be on the single constraints where you have key limiting factor. All right, where you have key limiting factor. That's our focus under optimal product mix. Okay, so the next we want to do now is to talk about the procedures involved in limiting factor. What are the procedures involved in optimal product mix or in limiting factor? And that's where we are going to stop today. So that in our next class, we are going to, all what we are going to be doing are just calculations. We are going to solve 4 different calculations, different scenarios, because that's the way examiner will ask you. So we have to touch each scenario. Now, procedures or steps involved in key limiting factor or in optimal product mix decision. So whenever you are given a question and you can identify that only one factor of production is limited in supply, an examiner is asking you to determine optimal production plan that will maximize contribution. Of course, there are about 7 or 8 procedures you are expected to carry out. So to do this, step 1 is to identify the key limiting factor. Identify the key limiting factor. So we said that the key limiting factor is that resource that is limited in supply. The key limiting factor is that single resource that is limited in supply. So how do you then identify the key limiting factor? Okay, this can be done. Let me put it down for you. This can be done by comparing, let me write it, by comparing the required resources, with the available resources. With the available resources, whether it will result in a shortfall or surplus, in a shortfall or surplus to the organization. Okay, using the table below. So in a question under optimal product mix, the first thing you are going to do, examiner will tell you that raw material is limited to, let's say for example, 100,000 kilogram, or labor hour is limited to 300 hours. you are not going to listen to what examiner is telling you because you have responsibility. Onus is on you to confirm from the question if truly the resource given to you is limited in supply. So to identify the key limiting factor, what you need to do is to compare the required resources with the available resources, whether it will result in a surplus or a shortfall to the organization. Okay, to do this, you can use these formats. Okay, we create about 4 columns. The first column will be the products. Okay, before that, you can just say confirmation, confirmation of insufficiency in key factor. Certainly, examiner will give to you the key factor. You are going to be told, the examiner will give you a clue about the key factor, whether it is going to be raw material, kilogram, or labor hour, or machine time. You will surely be given. All right. So the first column will be the products. Then you can have units, either units demanded or whatever. Then you are going to have key factor per unit, key factor per unit. It could be material kilogram, it could be labor hour, it could be matching hour per unit. Then we have total key factor. Okay. So let's say we have product A, B, and C. So you want to compare the required resources with the available resources, whether it will result in a shortfall or a surplus to the organization. Okay. All right. So I will then come here. You are going to pick. You go to the question. At times, the unit may not be given to you directly, but the information will be there to determine the unit. So just put the unit here. Then the key factor per unit, it could be the key factor could be raw material kilogram or matching hour or matching time, whatever it is. So you are the one that will determine, oftentimes, you are the one that will determine the key factor per unit. I will show you how to do it for material and labor. All right. So to get the total key factor, you multiply the units with the key factor per unit. So you post, then you add everything together. This will give you total required key factor. Okay. Then you compare this total required key factor with the total available key factor. Total available key factor. All right. So if the total required is more than total available, then of course, that means there is a surplus. But if total required is less than the total available, that's a shortfall. Okay. So shortfall or surplus. Okay. So like I said, if A, let's say this is A, then this is B. Okay. If A is greater than B, if the total required resources is more than the total available resources, then of course, say for example, you need 100, you need 100. What you have is just 80. That means there's a shortfall. All right, that means there's a shortfall. So if A is greater than B, there's a shortfall. there is a shortfall. But if A is less than B, then there is a surplus. So if what you require is less than what you have, let's say for example, here you need, here, let's say for example, here you need 70. Meanwhile, you have 90 available. What you need is less than what you have. So that means you have surplus. All right. So if the total required resources is less than the total available resources, there will be a shortfall. Okay. Now, notes, factors of production. Factors of production include 1. Raw material kilogram. Raw material kilogram. So what this simply means is that if you are given material cost, you need to convert it to uh, raw material kilogram. Okay. If material cost, because oftentimes material cost will be given to you, not kilogram. If material cost is given, it should be converted. It should be converted to material kilogram as follows. So, if in the question you are given raw material cost, you need to convert it to material kilogram. So I would then say material kilogram equal to the material cost divided by, okay, divided by material per unit. All right, divided by material per unit. Okay, so that will give the material kilogram. Then number 2, factor of production could be labor hours. All right. Again, if labor cost is given to you, if labor cost is given, it should be converted to labor hour because you don't use labor cost, you don't use material cost. It starts to be material kilogram or labor hour. It should be converted to labor hours as follows. Okay, so in this case, I would then say labor hour equal to labor cost divided by labor rates. All right, so labor cost divided by labor rate will give you labor hour. So we are still on step 1. So I will then move to step 2. In step 2, you confirm if management has placed priority. Okay, confirm or check if management, let me write it out in full. If management has placed priority, okay, or given minimum allocation, or given minimum allocation to each product line, to each product line. If not, proceed to the next step below. All right. So step 3. Step 3 says calculate contribution or saving per unit. Calculate contribution or saving per unit of the key factor per unit. How do you calculate contribution? Of course, you know contribution is calculated as selling price minus variable cost per unit, or contribution equal to fixed cost plus profits. Okay, so that will give you contribution per unit. Note, I said that you should calculate contribution or savings per unit. So savings will only arise. Savings will only arise if it is optimal mix involving make or buy. Make or buy. When we did make or buy, we calculated savings or deficits. All right. So when you have optimal mix involving make or buy, that's only when you have savings. So watch out. Step 4. We're almost there. Step 4. You calculate key factor, you calculate contribution, calculate or determine contribution / saving per key factor. Okay, how do you do this? It's very simple. Let's say, for example, you have 3 products, or let's limit it to 2 because of time. So let's say, for example, we have 2 products, product A and B. This is the format you are supposed to use. Okay, so we have product A and B. So you are going to pick the contribution or saving of each product. Then you consider the key factor per unit. Key factor per unit of each product. Then you then say contribution. For example, contribution per key factor. Let me shift this one to the front. Okay, contribution per key factor. Let's say this is A, this is B. So contribution per key factor will then be A divided by B. So whatever it is, A divided by B, put it there. Then you now do your ranking. Step 5. Okay, let me merge everything to determine savings / contribution per key factor and ranking. Let's merge it together. Let's merge step 4 and 5 together. So I will then call me a ranking. So you are supposed to rank the contribution/savings per key factor in a descending order. That is, according to the highest contribution per key factor. So you rank it. Then step 5, even though ranking is supposed to be step 5, but I've already matched it with step 4. So step 5, you prepare allocation table. Prepare allocation table. In this allocation table, you are going to create about 8 columns. The first column will be the ranking that you have done. Then the product that you have ranked. Okay. The units. Then key factor per unit. It could be material kilogram per unit or labor hour per unit. We have total key factor. Then we have cumulative. Because of space, I have to shorten it. Total key factor. Then we have balance. Then we have optimal product mix. 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 columns that you are supposed to create whenever you want to prepare your allocation table. All right. We're almost there. So let's say in the ranking, this is first, second, third. So that in our next class, we'll just be doing calculation only. Okay. So just put it there. It's very interesting. Optimal product mix is straightforward and very interesting. It's not difficult. All right. So that's that. This is the format to prepare your allocation table. Step 6. We have 2 more steps. Step 6. You determine the optimal product mix or production plan, optimal production plan. How do you do this? Of course, you are going to pick whatever information you have here in this step 5, whatever you have as the last column of step 5 will represent your optimal production plan. So you put it there. But if in the question you have given minimum allocation, that means you are going to have 2 components that will make up your production plan. The initial allocation, the minimum allocation that you have given, and then the allocation you have done in step 5. So those are the 2 elements that will be there. If it's a question that involves optimal mix involving the minimum allocation. Then finally, step 7, determine, okay, determine the profit achievable, the profits achievable or derivable from the allocation. Let me rewrite it. From the allocation. So in this case, just prepare the income statement. That's all. That's the procedures. So like I said, anytime you want to determine optimal production plan, the first thing you are going to do is to identify the key limiting factor. Whenever you want to determine optimal production plan under single constraints using key limiting factor, you identify the key limiting factor. Then step 2, you confirm from the question, or you check if management has placed priority or given minimum allocation to each product line. All right. But if that does not arise, then you move to step 3. In step 3, you calculate contribution or saving per unit. All right. Then step 4, you determine contribution per key factor and rank your results. Okay. Then step 5, you prepare allocation table. All right. Step 6, you determine optimal production plan. And step 7, you determine the profit achievable from the allocation. So these are the 7 procedures. You can make it 7 or 8 procedures in relation to optimal production plan or optimal product mix. That's end of today's class. Let me know if you have any question for me. I really appreciate for some of you that waited behind, even though I extended beyond the normal time. Thanks for your patience. Some of you have disappeared. No worries, it's understandable. Yes, let me know if you have any question for me so that we can close the class. Okay? So, in the absence of no further question, I want to say thank you, everyone. Yeah, let me see. I can see Andrew. Abraham is still on. All right. Yes, I can also see Angela is still around. Ayodeji, David, Femi, Omke, Joy, Michael, Omowumi, Orobo, Oreoluwa, Priska, okay, Rose. I greet every one of you and I say thank you for waiting behind. I
Thank
will
you, sir.
see you. You're welcome. I will see every one of you next week by the grace of God when we shall be starting illustrations. Okay. Thank you. Good night. Bye bye.